Good afternoon and welcome to another ASA ABLOY webinar. Today's webinar is Upgrading Opportunities with Corbin Russwin Motorized Electric Latch Retraction and the installation of the MELR kit. My name is Russell Corvo and I will be your lead instructor today. This session should last about 50 minutes. During the session, your lines will be muted. However, you can pose questions using the question and answer icon at the bottom of the page. We will reserve time at the end for your questions. This session is being recorded and will be available within 24 hours for viewing. Within 24 hours, you will receive an email as your proof of attending this webinar that can be submitted to your employer or one of the industry association partners such as DHI or LOA for industry CEUs in lieu of a certificate of completion for these short trainings. In addition, ASA ABLOY Academy has over 50 online courses that are all available at no cost. To get started, simply create an ASA ABLOY Academy account and learn at your own pace. Okay. At ASA ABLOY, safety is always our top priority, so make sure you're always wearing the proper equipment. Make sure you're wearing the equipment for the job you're doing. In this presentation, we're going to examine the Corbin Russwin MELR electric latch retraction exit device and the opportunities to upgrade with electric latch retraction. First, what is motorized electric latch retraction? Motorized electric latch retraction is a means of retracting the latch bolts electronically, usually of an exit device, either momentarily or continuously. In general, solenoids have been the primary method used by most companies, including Corbin Russwin. A few years ago, Corbin Russwin incorporated a motorized design for their electric latch retraction opposed to the solenoid design they had previously, and it offered some really nice advantages. Corbin Russwin uses a linear motor, which is also known as a step motor for their electric latch retraction, which is a very different motor than the standard motor. We'll take a look at it shortly. All electromechanical products from Corbin Russwin will come standard with Electrolinks, with the Electrolink system, which is a foolproof plug-and-play connector system. Taking a look at some of the features and benefits of the MELR, you'll find that it generates very, very little noise during the activation for quiet environments such as hospitals and schools. The MELR also requires very low current draw, far less than what you would have, far less than the requirements for a solenoid, and therefore you don't need to have a special controller. Normally, when you have a solenoid electric latch retraction exit device, you require a special power supply, usually called the controller, because you need a capacitor in there. With a motorized electric latch retraction exit device, you can use a standard power supply along with standard electric hinges. Corbin Russwin's As I mentioned, Corbin Russwin's motor isn't just any type of motor, it's a linear or step motor, which is actually quite different. Shown is an end view of the motor, and due to its unique design, the step motor uses a multiple geared tooth-shaped iron piece surrounded by multiple magnets slightly offset, which can be controlled with a great deal of precision. The shaft on these motors move in and out, opposed to rotating as most motors do. So it's a very different type of motor. The initial power requirements for the dogging cycle for the ELR device varies greatly from solenoids. Typically, like for example, the Von Duprin exit device, their Von Duprin solenoid operated exit device, the EL, required a 16 amp inrush. While the Corbin Russwin, you can use just a standard 24 volt power supply and it requires less than a 1 amp inrush, which makes it a lot simpler. Corbin Russwin's MELR device will work properly on anybody's 24 volts filtered and regulated power supply. With solenoid electric latch retraction exit devices, a special power supply is required. And as I mentioned, it's usually called the controller. And what the controller has in it is a capacitor. And what a capacitor does is it stores up electricity and allows the electricity to be released very quickly at a controlled rate, such as 16 amps. which is required for the solenoid. Most solenoid electric latch retraction exit devices require an EPT, or electrical power transfer device, to transfer the electricity from the frame to the door due to the large inrush required by the solenoid. In addition to the additional cost for the door prep and the frame prep required for the EPT, the issue with this solution is that the EPT makes it very apparent that the door is electrified. With a motorized electric latch retraction exit device, it can be used with a standard electric hinge or an EPT. The advantage of a standard electric hinge is that all the wires are completely concealed and there's nothing revealing that the door is electrified. Corbin's MELR device has a built-in timer. By adjusting the 3 dip switches on the far right, you can adjust the timer from 0 to 20 seconds. The timer is a great feature when the device is being used with a momentary switch. The timer allows the rail to remain retracted for a set period of time. The MELR device is equipped with a diagnostic feature. By removing the end cap, the controller and the diagnostic LED become visible. And when I was referring to the controller, I'm referring to this is called the controller, and it's not like a power supply controller. It's just the controller for setting up the MELR kit. So right here, there's an LED, and this LED will blink to inform you of certain information. For example, steady flashing indicates normal operation. So normally you should have steady flashing there. While if you had a solid LED, that would indicate that the input voltage has dropped out of range. The MELR device retracts not just the latch bolt, but it also retracts the push rail also, eliminating the noise of the push rail going in and out as someone exits the door. You'll find that some manufacturers only retract the latch bolt, so you still get the noise of the push rail moving in and out as someone passes through the opening. The MELR, Motorized Electric Latch Retraction, is available with standard cylinder dogging, which is specified as an M52 quick code. And the reason I mention that is some manufacturers, if you want cylinder dogging, in addition to the motorized electric latch retraction, it moves the cylinder dogging to a different part and it makes it a special product. With Corbin Russwin, it's the standard cylinder dogging. Taking a look at some upgrading opportunities with motorized electric latch retraction, we'll take a look at these. Oftentimes ELR devices, sorry about that, one more time. Oftentimes ELR devices are used in conjunction with low energy operators to meet ADA requirements, which is the American Disabilities Act. I apologize, which is the American Disabilities Act. With electric latch retraction exit devices used in conjunction with a low energy operator, a difficult problem is resolved. With the use of a wave to open switch on both sides of an opening, a challenged individual can easily access a public building simply by waving their hand in front of a wave to open switch, initiating the electric latch retraction, followed by the operator opening the door, allowing passage. The advantage with the ELR device, opposed to a solenoid operated device, opposed to a solenoid controlled mortise lock or cylindrical lock, is that with an ELR device, you're actually retracting the latch bolt. With solenoid control operated mortise locks and cylindrical locks, all you're doing is unlocking the lever handle, and the lever has to still be retracted to rotate. And the lever still needs to be rotated to retract the latch bolt, and therefore they cannot be used with low energy operators. Okay. When Corbin Russwin's MELR is used in conjunction with a Norton low energy operator, the cost of the power supply is completely eliminated. In case you were not aware of it, the Norton 6000 series, 5700 series, the 5600 series, and the 5500 series operators all have an onboard power supply offering 24 volts DC at 1.1 amps of power or more. 1.1 amps is more than enough power to operate Corbin Russwin's electric latch retraction, which is the preferable way of powering the exit device when used with a low energy operator. If a solenoid operated electric latch retraction was used in this example, a special power supply or controller would be required, and you could not use the operator's power supply. Office entrances are usually designed to be inviting, and are often easily accessible to the public, which causes a number of concerns in today's society, the first of which is security. So how do you keep the entrance inviting as well as secure? At this point, you probably know the answer is electric latch retraction. Simply secure the opening with an electric latch retraction exit device with a momentary switch easily accessible to the receptionist. As the receptionist sees a friendly face approaching the door, with the touch of the button, the receptionist has turned the locked door into a push-pull door, allowing the person to pull the door open. This process can also be done with the timer, so the button doesn't have to be held in until the person pulls the door open. Employee entrances are also another great opportunity to upgrade security of your building with electric latch retraction. Employers need to grant access to employees while keeping the door secure and preventing those who are not employed from gaining access. With electric latch retraction exit devices are available with many of the electric latch retraction exit devices are available with many of the Corbin Russwin access control technologies, including Apereo, Wi-Fi, and PoE, to name a few. The employee's ID can be used as a credential to gain access to the building, which will also record the time that it was used. Schools must be kept safe and secure so the children are not endangered. So what would be simpler than having electric latch retraction on the school's front doors? So at 7 a.m., the doors unlock and then automatically relock at 8 a.m. at the beginning of the school day. With the use of door position switches and latch bolt monitoring, the school officials can verify that the building is secure from a remote location, freeing up the custodian to do more important things than dogging or undogging doors every day. This process can easily be repeated at the end of the day, at the end of the school day. This will be the last example of an entrance for upgrading. High traffic areas within schools, such as cafeterias and gymnasiums, as students pass through these doors, they usually push on the doors or they're rotating the lever handle. Even though most think the easiest way of exiting a door is by pushing on the push rail, some take this opportunity to test the quality of the hardware in the door. The simplest way for the hardware to pass these tests is by eliminating any resistance. So with electric latch retraction exit devices used on these doors, the latch bolt will be held in the retracted position, eliminating the movement of the latch bolt and allowing free flow of traffic through the doors. So Corbin Russwin's MELRs, Motorized Electric Latch Retraction Kits, are available with the Corbin Russwin ED5000 and the ED4000 series exit devices. Okay. First, we're going to take a quick look at how to order them. Okay, so with Corbin Russwin, when ordering an exit device, the ED specifies exit device followed by the series. A 5 would specify the 5000 series. The 4 would be a 4000 series. The 3 is a 3000 series crossbar style. The 7 is a narrow style crossbar design. And the 8 is a push pad exit device. Motorized electric latch retraction are only available for the ED4000 and the ED5000. Next we have the exit device type, which is designated immediately after the series. The 2 digits the 2 would represent a rim exit device. A 2 and an S after the 2 zeros designates the secure bolt. A 6 designates a mortise lock exit device. A 4 would designate a surface vertical rod exit device. And an 8 would designate a concealed vertical rod exit device. And motorized electric latch retraction is available with all of these exit devices. Next, when ordering the Corbin Russwin, you have the trim. So with Corbin Russwin, we have the lever design followed by the function. There's a very large selection of levers, including the designer series, are available with the 900 series trim that's used with the exit devices. Followed by the trim. In this case, we have a 900 series trim, which is being used with the C represents a citation lever. It's the 900 series trim. That's why you have the 900. And the last 2 digits represent the function. 10 would be a passage function, 950 would be a dummy function, 955 would be a classroom function, 957 is a night latch function, and 959 would be a storeroom function. This is a little side note, but I thought you should be aware of it. If you're not aware of it, Corbin Russwin's 9000 series exit device trim is now field selectable, fail safe, or fail secure. By moving a small toggle switch in this area here, you can switch it from fail safe to fail secure. Also, the trim is fully functional on 12 or 24 volt power supplies right out of the box. Keep in mind that Corbin Russwin's trim is freewheeling, so it rotates when it's locked. Okay. Another thing I just want to mention, which I thought was pretty neat, is that the 900 series trim is a multifunction trim. When this is assembled, you have this little screw here. By having the screw on the left side, it would make it a classroom function. And by moving it to the, by having it on the left side, it's a classroom function. And having it on the right side, it becomes a storeroom function. So you can change the function of the field without even specifying it ahead of time. Next, you have the finish, of course, and then we have the hand. Exit devices are always reverse bevel. And then you have any quick codes for special door things. So in this example, they're looking for a 48-inch door, so they're specifying W048. And lastly, we have the designation for the Motorized Electric Latch Retraction exit device, which is MELR. Okay, before upgrading your exit device, you need to take a look at the latch bolt head pins to determine if the MELR kit can be incorporated into your exit device. Exit devices manufactured prior to April of 2015 will have short pins and cannot be upgraded unless the chassis head is replaced. Exit devices manufactured after April of 2015 will have long pins, and these exit devices can be upgraded with the MELR kit. The Motorized Electric Latch Retraction kits, the part number specifies the kit whether it's going for a 36-inch door or a 48-inch door width. The kits can also be ordered with an M107 windstorm certification, which is only available with the ED52000 secure bolt exit device and the ED5470 surface vertical rod exit device. If your exit device has pre-existing outside trim monitoring, which is M93, the Motorized Electric Latch Retraction can be ordered with M93, so the wires will run through the exit device opposed to the door. A few other items to be aware of is for exit devices that use the M91, which is the bolt position monitoring, simply connecting the wires from the existing switch through the exit device. For exit devices that have the M92 option, which is the request to exit switch, existing switches need to be moved and wired into the new rail. And one last comment. The old controller that Corbin Russwin used to use with their solenoid operated device was a 782 controller. The 782 controller cannot be used with the Motorized Electric Latch Retraction. Next, we're going to take a quick look at the installation. Now we're going to go through the steps to upgrade a mechanical exit device with an MELR kit. The first three steps are to remove the exit device from the door and to place it on the workbench. The next step is to slide the insert out of the rail assembly, as shown there. Next, we need to remove the push rail end cap. This is accomplished by removing these two screws. Now the push rail end cap needs to be removed from the exit device. This is going to be done with a T20 torque head driver. With the two screws removed, now the push rail end cap can easily be removed from the push rail. Push rail scallop will easily slide off the rail assembly. Okay, simply slide the scallop off the rail assembly. Next, we need to remove the mounting rail scallop. That's also just slid apart. We need to flip the rail over and remove the chassis head. To do that, you'll need to remove these three screws. Now the head of the exit device can easily be removed from the rail assembly. Now we have to attach the new MELR mounting rail assembly to the chassis head. This is going to be slid together in this manner, just like that. I'm going to match up the screws. Now the rail is ready to be rescalped. Next, you take the mounting rail scalp. You slide it into position. When you slide it together, make sure that the wires are laying flat. When you slide it together, make sure these wires are laying flat so it doesn't interfere with the movement of the rail assembly. Next, the push rail scalp. Once again, that's just slid on from the end. Slid right on. Once the push rail scallop is in place, it's now time to install the push rail end cap. Once the end cap bracket's in place, okay, if your exit device is a non-fire rated exit device, the hex key dogging mechanism needs to be taken out of the old exit bar and moved to the MELR kit. It's going to be installed in the exact same area as it was in the old bar. This is accomplished by removing two identical screws and relocating the dogging assembly into the new MELR bar and securing with the two screws you just removed from the old device. After installing the mechanical dogging assembly, mechanical dogging needs to be checked to make sure you're getting full retraction. If you're not getting full retraction, or if the latch bolt retraction is not sufficient, adjust it by lifting up on the latch hook with the screwdriver as shown here. To install the insert, you're going to slide the insert in from the end. You're going to feed the wires underneath. And don't forget to put them this part here. Goes right up against the rail. Now it's time to install the wire protector. The wire protector is installed in this manner right here. This prevents the wires from getting affected by the dogging mechanism. Yes, the wire protector prevents the wires from damage from the dogging assembly and the movement of the touch bar, assuring all the wires go through the opening as shown in the bottom here, in the image here. Next, you have to plug in the ribbon cable into the underside of the controller as shown right there. So this is the plug location and it only plugs in one way. The controller is what's installed next. You need to connect the controller to the device. This connector plugs right into the back right there, just like that. Once you have that, now you're going to take this whole controller, you're going to slide it into the end of the rail, being careful to make sure that it engages the bottom of the rail assembly right there. Now the rail is ready to be reinstalled. The layout you see here of the controller has changed. This is what the new controller looks like, is this right here. It's laid out this way. It makes it easier to read. Everything else is identical. All the switches do the exact same thing as it did previously. So they did it just for ease of use and to make it a little easier. And keep in mind that it still does clip to the inside of the rail as shown right in this area here. So that's critical that you clip it onto there. Next, we'll take a look at the configuration of the controller and what each of the toggles does and the options available. Taking a look at the toggle switches on the controller, which are these toggle switches here, starting from the left, the LBM switch monitors the latch bolt position and is designated as an M91 quick code. Switch number 1 is set to the on position and switch number 2 is set to the off position when selecting to monitor a normally closed M91 latch bolt monitoring switch. Switch number 2 is set to the on position and switch number 1 is set to the off position when selecting to monitor a normally open M91 latch bolt monitoring switch. So with this here, we didn't have enough wires to monitor both normally open or normally closed. So we used the switches on here so you can designate, do you want to monitor normally open or normally closed? If the latch bolt is not being monitored, these switches will have no effect at all. There are two modes to the MELR device. When dip switch 3 is in the on position, the device is in the power mode. In this configuration, the device is not energized when locked. When energized with a 24-volt input, the push rail and the latch bolt retract and will remain retracted until the power is removed. Power is typically applied through a relay trigger, such as an access control product. In the power mode configuration, only 3 wires are needed. The positive terminal of the power supply is connected to the common terminal of the activation device, such as the power operator, the access control system, or possibly a card reader. The normally open contact of the activation switch is connected to the red wire of the exit device. The negative terminal of the power supply is connected directly to the black wire of the exit device. And the green wire of the exit device is used to ground the exit device. So when the activation device is acted upon to close the switch, the exit device will retract the latch bolt and remain retracted until the circuit is opened again, cutting power to the exit device and causing the exit device to become undogged. There's also a timer mode with this. The dip switch number 3, when it's in the off position, the device is in the timer mode. In this configuration, once again, the device is not energized when locked. When an activation device is acted upon, the circuit will close and the push rail and latch bolt will retract for a set period of time ranging from 0 to 20 seconds. When the set period of time ends, the circuit will open, cutting the power to the exit device, which allows the exit device to become undogged. Power is typically applied through a trigger, such as an access control device. Only in the timer mode, the last 3 dip switches are used to set the length of time the exit device will remain dogged. So this is right out of the instruction sheets or the instruction manuals, and it tells you how to set it if you're using it in the timer mode. So you can set it for 0 seconds all the way up to 20 seconds, depending on how you configure these last 3 toggles. Other than that, the 3 toggles do nothing if you're using it in the power mode. In the timer mode configuration, only 5 wires are needed. The positive terminal of the power supply is connected to the red terminal of the exit device. The negative terminal of the power supply is connected to the black wire of the exit device. And the green wire of the exit device connected to the ground is used to ground the exit device. So what is needed next is a means of activating the electric latch retraction exit device. Okay. In the timer mode, the pink and the tan wires are used as dry contacts to initiate the activation of the device. The pink wire is attached to the common of the activation device, while the tan wire is connected to the normally open contact of the activation device. So when the circuit is closed, the exit device will dog and remain dogged for a set period of time. The pink and the tan wires are located within the 4-pin connector. Okay, so you use these 2 wires to your activation device, and there's no electricity running through them, but if you just touch the wires together, it will activate the exit device. So you'd activate it, and as soon as you separate it, the timer starts. Okay. Okay, okay. As we discussed previously, your exit device, if your exit device has pre-existing M93, which is outside lever monitoring, the kits will be ordered so this feature is not lost. It can be connected to the access control system. With the M93 option, the factory preset is to the normally open, but can be reconfigured to the normally closed position. This is accomplished by moving the trim monitoring switch wire harness to the desired configuration. The image on the left shows the factory preset. So this wire there's two pins coming up here, and there's 3 pinholes. So if it's in this position here, it's in the normally open position. And the image on the right shows how it must be configured to monitor a normally closed switch. Okay. The MELR, as I mentioned earlier, has built-in diagnostic. By removing the end cap, the LED becomes visible, and the LED will blink indicating the status of the exit device. So once again, steady flashing means normal operation. Solid LED indicates that the input voltage has dropped out of range, so it's no longer getting 24 volts. They could have mounted the power supply too far away, so you would take your multimeter and check to see how much voltage it is getting, because you're probably not getting enough voltage for some reason. If you have 2 flashes by a pause, indicates that the retractor assembly has a problem. And the diagnostic interpretations can be located in the instruction manual received with the product and is also available online. Okay, if your motorized electric latch retraction exit device is going to be used in conjunction with a low energy operator, it's critical that the latch bolt retract completely before the operator attempts to open the door. The preferable way of accomplishing this is to have the operator activated by the M91 latch bolt monitoring switch. So when the latch bolt retracts completely, the M91 switch activates the operator to open the door, ensuring that the latch bolt is retracted completely as the operator opens the door. Another option would be to use the delay activation of the low energy operator. So within most low energy operators, you can set an activation delay. So when someone hits the activation button, it will activate the electric latch retraction immediately, and then 750 milliseconds later, the low energy operator will start to open up the door. This gives enough time for the latch bolt to retract completely and then the door to open. And that actually brings us to the end of our presentation on upgrading electric latch retraction. So I'm going to open this up to see if we have any questions. Hopefully this made sense. If you don't have any questions, I really appreciate you taking the time out and joining me for this webinar today. Keep in mind, ASA ABLOY Academy is offering multiple webinars a week. Please join us for future webinars. It appears we do not have any questions, so thank you very much, everyone. Have a great day and stay healthy.